Autoline After Hours is brought to you by Bridgestone Tires, your journey, our passion, and by Henkel, excellence is our passion.
This is Autoline After Hours with John McElroy, episode 321 for February 26 of 2016, a PhD in GM Propulsion. Watch Autoline After Hours live at Autoline.tv every Thursday at 3 p.m. Eastern Time. That's 12 p.m. Pacific or 20 hours GMT. You can subscribe to this podcast for free by searching for Autoline in iTunes, Stitcher, or YouTube. Mr. Vasilash.
How are you?
I'm doing pretty good. You ready to talk powertrain?
Yeah, and I was thinking driving over here, listening to the traffic report, and they're warning of giant potholes on Southfield, and I was thinking that $3 billion a year we talked about last week on the show for pothole repair is going to be going up.
Yeah.
Huge potholes.
Hey, we got to let everybody know that Bill Visnic is joining us from SAE International. Bill, great having you here.
Thanks for having me. I appreciate it. Thank you.
And we got to tell you, we've got Dan Nicholson, the Vice President of GM Propulsion, Global Propulsion Systems.
Yep.
And he's also brought some hardware in with him, and we'll get into that in a minute. But Dan, thanks so much for coming on the show
John,
today.
thank you very much. It's a real pleasure to be here.
Okay, we've got this engine here in the studio. We got to talk about it. C7R race engine.
Yep.
You take it from here.
Yeah, thank you very much. It's the elephant in the room, or more the race engine in the room. So Russell Blenis and our racing guys were kind enough to bring this here. We thought it would add some ambiance and some atmosphere for today. So this is a race engine from our C7R race program.
The Corvettes.
Exactly.
Which went 1-2 in their class at the Daytona 24.
Thank you very much. Very exciting race at Daytona. It was awesome this year. This engine will go in race cars at Sebring and Long Beach. So it just came out of the dyno, made its way over here, and will be seen soon in a Corvette at a racetrack, so in the IMSA series. So that's really great. This is a piece of history. This is the last engine to ever run at our Wixom Race Center facility. As you know, we've recently opened our Performance and Racing Center, co-located with our engineering center in Pontiac, Michigan. So the race guys are moving in together, all in one house in Pontiac. And so they've got their new dynos there, and we just shut the Wixom labs down just a couple of days ago.
So this was built in Wixom?
Yes, built in Wixom, ran on the dyno in Wixom, and we'll go to the racetrack.
In fact, we just had a bit of a clip up there. Carmen, maybe we can run some of that stuff right now, because I went to that race center.
Yeah.
And look at this whole facility. It's enormous, gigantic. And this is where you do all your propulsion development, right?
Yes, this is our Pontiac Engineering Center for Global Propulsion Systems at General Motors. It's really state-of-the-art and one of the best powertrain development centers in the entire world. And the Performance and Racing Center is that new area on the corner, again, co-located with our production systems. So we can have a great two-way street and technology transfer between racing and production. And I say two-way street because it's not just racing lessons that are brought into production, it's actually production lessons that are then technology transferred into racing. So it's a two-way street, and by co-locating, we're hoping to turn that two-way street into a superhighway.
Well, look, you're talking to a hardcore racing fan. I've been that all my life. I always love how racing pushes technology that can help production cars.
Yep.
How does the opposite work? What are you learning in production that you're applying to your race engine?
Well, one great example of that is direct injection. And so as that started getting introduced into racing series like Indy Racing League, there wasn't as much, race knowledge about that. So we actually used a lot of production knowledge to help design those systems to be quite effective, and it's really done well for Chevrolet in the Indy Racing League. We won the Manufacturers Cup last year. And we're quite successful. So that's just one example of what we do going back and forth. The other example probably is analysis techniques. So all this computer-aided engineering that is so critical for production is absolutely critical for racing as well. And so the codes we use, the techniques we use for analysis are also shared between production and racing.
So how common is that engine to an engine that someone might get at a local Chevy dealer?
Yeah,
in a Corvette.
It's great. This is actually, so this is a roughly 500 horsepower, 5.5 liter, but it is off our famous small block family. This actually started out, that engine block started out as an LS7 block. It's been machined differently because it's bored and it has a different stroke for the 5.5 liter. So it actually started out as an LS7 block. And as you know, the legendary LS7 just went out of production. I happened to be the chief engineer when that debuted in 2005, so that one's pretty near and dear to my heart. So there's really a lot of small block, I think, that you would recognize in this C7R race engine. Yeah.
The machining is one thing that you've taken to the new Pontiac place, right? So all the race engines that you use in racing are machined there. Is that right, Tim?
That's correct.
Yeah.
Well, not all of them. Certain series are all the ones that we do.
Right.
So you're right. We've got beautiful, brand new CNC machining, a great machining center in Pontiac, supplemented by the other.
We got some video of that running now, too.
Yeah. These are beautiful state-of-the-art machines, and to see those cylinder heads and the connecting rods and the blocks come out. I mean, it's
amazing. It really is.
It's really jewelry to engineers in the business. We love it.
So how many engines would you produce for racing on an annual basis?
Yeah, I'm not sure exactly the number. We've got master builders, so it's in the hundreds, not the thousands.
It's not in the tens.
But each one is, it's hundreds. Each one is very carefully and meticulously put together by a real seasoned master builder. And we've got some of the best in the business.
So I got to believe that you build all the engines for whatever GM's racing in, at least in North America, except for Indy.
Yeah, correct. We have partnerships for the Indy, and of course for NASCAR, those are also built by some of the teams. So we consult technically on the NASCAR engines, but the teams are building their own. We also build the Copo engine. So if you buy your Copo Camaro, that is drag race
for those who don't
exactly.
know, right?
Yeah. So those are hand-built engines by our team there.
In fact, there's only a lottery to get them, right?
Yeah, they're
to get the cars and the engine.
It's in pretty good demand. Yeah, it's really.
And you
those are
build
exciting
69
products.
of the cars.
Yes.
And you build
correct.
probably a little bit more engines than that.
Yes.
But
yeah, you can buy Chevrolet, the racing and aftermarket parts and accessories. You can still get LS7 engines. You can get great racing engines from your Chevrolet Performance Parts catalog. It's really outstanding stuff, and that's where we're doing it with our racing and aftermarkets guys, Russ Oblinas and his team. They're really quite special.
None of those crate engines, though, that say someone would come and buy for you as a complete engine, none of those aren't made in the new Pontiac facility,
Well, they're
are
made
they?
in different places.
Okay.
The Copo engines are made in Pontiac. The other engines come from various places, depending on which ones. Yeah.
So it's clear General Motors is really embracing racing in a big way. I mean, was there ever an issue that, that they would say to you, we're not so sure that we want to continue to do this?
Well, I can't recount the entire history, but what I do know is the last 5 or 6 years of history, and I was in actually some of the first meetings 6 or 7 years ago, let's call it after reorganization, where Mark Royce and at the time Tom Stevens were very much hand in hand on commitment to racing and racing for Chevrolet, Cadillac. And Mark is a huge champion for that. And Jim Campbell has been the real guy that's been the consistent part in that and really making Chevrolet winning. Jim's a great partner. He does all the marketing part of it. He lines up the teams and everything. And we just support him from Global Propulsion Systems with really the engine technology and the things we need to do to make those the cars go and hopefully win. And we've had quite some success, and we're deeply committed to it. It's working for us.
one thing I liked about co-locating your racing organization with the rest of the engine development is you guys have talked about using that as a recruiting tool.
Yeah.
And in an industry that is having a hard time bringing new talent into the industry, that's got to pay off.
Yeah, thank you very much for that. A couple things. Actually, this morning I reviewed with my HR team the results of our recruiting, on-campus recruiting. So now I'm talking about new college graduates. And we got over 70% acceptance rates. And we are recruiting at the top universities in the nation, including Stanford University. I'm a proud alum from there, and we're doing great with the talent that we're bringing in. So
here's this old rust bucket image, rust belt image, bankrupt company, and yet you're recruiting some of the best from Stanford.
Yeah, because they want to be part of the future. They want to do something great. Younger people are very interested in designing their own future, and they're not going to wait for old guys like me to do it for them. So they're really excited about being part of that, and we're able to go to campus, tell our story. As part of our process, we bring them back to Detroit and say, here's where you're going to be working, here's what you're going to be doing, and we get them to intermingle with engineers, management, and other college graduates. Here's who you're going to be working with, and they're really signing up for it. So let's say the icing on the cake for people that are deep performance guys is, hey, you get to see the Performance and Racing Center in Pontiac, and that's a nice kind of cherry on top. So it's really multifaceted. So having it in Pontiac co-located is doing really a number of things for us, and we were really happy to open that up to the press and get everybody to see what we're doing in Pontiac and really building our future. And we want this, again, the Performance and Racing Center, to be part of the community. And so we're going to be opening that facility up for rentals in case.
In fact, here's the lobby.
Yeah, that's
we
a
got
great
that
beautiful
there.
lobby with a beautiful active screen.
So say that again.
Yep.
Outside people can come and rent this
Yes.
as a facility.
Starting in August, we're going to be making it available because it's really beautiful and it's interesting. There's a lot of racing nostalgia in there. So we think car clubs, suppliers will gravitate to this, and they'll find it a really fun and interesting place. And what would be better than having, sort of an evening party, even as a warm-up to Dream Cruise, to come here, hang out with 100 of your closest friends, maybe have a drink and some hors d'oeuvres, and really enjoy the space, and then head out and watch the Dream Cruise.
We make engines in a profit center.
Yeah, well, yeah, I don't think that's not our main motivation is money making. Of course, we're charging because it has some wear and tear on the facility, but we want to make it a space for people, and we think it's a very interesting. You've been there, so you know what a kind of interesting place. And we've got 100 years of GM racing history on a super cool interactive screen. We've got engine dyno simulators, and so there's some fun interactive stuff that you can do as well as enjoying that. We've got race engines that are exploded with the actual parts you can look at. It's very visually interesting. It's a lot of fun, and we think it's going to be a great attraction.
You guys have the new name now for just a couple of weeks. Talk to us about that.
Thank you very much. So yeah, we announced that we've changed. We were GM Powertrain for 24 years out of our over 100-year history, and now we're GM Global Propulsion Systems. So this was a very important announcement for us. We did this for both, let's say, internal and external reasons. Global Propulsion Systems really acknowledges what we're already working on. We cover the breadth of propulsion. We're a portfolio manufacturer, and we have a portfolio of solutions. And so for people that are working on energy storage systems, i.e. batteries, electric drive units, this is a more inclusive name for them, and they can identify. And so that's one of the main motivations for doing it. Propulsion Systems also emphasizes the teamwork and the total systems engineering approach that is really necessary to be state-of-the-art, not only today, but going on into the future. So Global Propulsion Systems really is who we already are, and so we think it's a more fitting name that really describes it. Externally, I think people get it a little bit more that, hey, we're selling a portfolio of solutions, and I think it'll make a lot more sense to people in the industry, both the press as well as our suppliers and others that we deal with externally. So I think this will be a trend that you'll see probably other people follow. At the end of the day, customers, real customers that buy cars, maybe not the people watching the show, but other customers, what a powertrain. They don't really know what a powertrain is. And even for those of us in the industry, we tend to narrowly think of powertrain as engines and transmissions that somehow you bolt together and, it kind of works. But really, propulsion systems is much more descriptive of what we're actually doing.
And I think that's important to know. You know, when we showed that graphic of that huge facility, you're doing hybrids there. You're doing electric. You're doing fuel cell. You're doing everything in that building.
That's absolutely true. And we've got energy storage system testing, drive units, and we're really a propulsion system center, and the other engineering centers that we have around the globe. But we're working on a number of different things, and you got a chance to see some of those. And the test facilities we have for electric drive units is really exciting. In addition to, of course, our state-of-the-art internal combustion engines that we're very proud of as well. So we're not running from, you know, the great internal combustion engine things that we're doing, or, you know, transmissions, and we've got 6, 7, 8, working on 9 and 10 speeds, as well as CVTs. So those are absolutely critical and still a huge part of what we're doing.
And that's all in that building, too.
Yes, it is, absolutely, in our...
But does it reflect that you're going to be doing more work on different types of propulsion systems going forward?
Well, I expect that will happen. We're already doing lots of work on all kinds of propulsion systems. And in fact, in our press release, we pointed out that 50% of our people around the globe work on some element of non-traditional propulsion systems.
Now,
that doesn't mean we spend half our money or half our effort on it, but half of the people are touching that in some meaningful way. And a lot of that has to do with controls and all the things that we're really doing. So I expect that trend to continue in the future. And again, we're pursuing a number of different solutions because the way we see the future, there's going to be a number of kind of propulsion system solutions.
Yeah, so you're not going to tell us about the ionic drive with dilithium crystals today yet, right?
No, we don't. Yeah. We're not working on that one. We'll leave that to the good professor.
One interesting piece of news today was I saw you just announced it came through the divisions, but there's going to be a mild hybrid system for pickup trucks again for 2017 to bump a few miles per gallon on the full-size trucks.
Yes.
Which... who could argue with that, right? I think the cost I saw mentioned was around $500 or so. So that's something that you could recover even at $2 a gallon. I think particularly if you drove a truck a lot.
Yeah. Well, thanks for mentioning that. We're trying to provide customer-focused solutions that provide a value proposition to customers, and we think some customers in the full-size truck segment will find that appealing, and we'd like to provide it for them.
Well, certainly the law says you got to do it too. Hey, we got a phone call here. Carmen, let's bring in one of those phoners from the audience right now.
Hey, how you guys doing? Love your show. This is Lake Leahy in Jackson, Mississippi. A couple questions, or kind of a comment and a question. The success or pretty much sheer domination the Corvettes have had on the international tracks just makes me wonder if the push to the mid-engine thing is really a necessity. The Corvette has proven that pushrods can win on the world scale and world's racetracks, and so can the front-engine rear drive. So just curious about that. But also about the electric power steering. GM is supposedly one of the better people dealing with electric power steering from what I'm reading in the comments. And I was wondering if they ever thought about employing people from the sim world that use companies like Fanatec, Logitech, Thrustmaster, that have been working a long time perfecting electric synthetic type feedback. Just curious. Love you guys' show again, and keep it up. Thank you.
Yeah, well, let me take the second part of that first. I'm not a qualified chassis engineer, but I spend a lot of time with my colleagues at Global Product Development talking about ride and handling. Usually Friday afternoons, you can find us driving cars somewhere, and we exchange information, and my colleagues aren't shy about giving me their opinions about the propulsion systems, and likewise, I'm not shy about giving my comments on handling. So I'm not an expert, but that's where my comments come from. I do feel in benchmarking our electric power steering systems against the competitors that we focus a lot more on the feel of it, trying to make it feel natural and make sure it fits to the overall ride character of the car. So thanks for noticing. Really appreciate that. And we're pretty serious about delivering world-class steering systems. We do incorporate a lot of controls and that you're talking about. I don't know the exact firms that you mentioned, but there's a lot of control work that goes into making those systems feel great. And we partner with companies, and we have some proprietary techniques inside in order to accomplish that. So I think we're doing a lot of what you're suggesting already today. And then the earlier comment, thanks for pointing out, I think the Corvette's great state-of-the-art pushrod engines. I'm proud to be part of that and the history, and they're really having great track performance, which you mentioned, and great on the street as well. The new Corvette is really, really super hot. And then you said something about mid-engine, and I didn't really catch that comment. Don't know what you're talking about.
He knows nothing when it comes to that, right? Hey, we should take a quick, we got a lot more to get into. I know Gary and Bill got more questions, and we got more coming in from the audience, but let's take a quick break right now, and we're going to give a shout out to our friends at Bridgestone. We're back. Okay, who's next? Gary?
Ask him the question live.
I was curious, Dan, you know, everybody, I think, has responded pretty favorably to the name change to, you know, for those of us that have been around the business for a long time, powertrain has been with us, you know, under our skins for a long time. The change to Global Propulsion Systems, I would imagine maybe that does help a little bit out in the recruiting when you go to campuses and you're up against the Googles and the Apples of the world, right? It doesn't sound bad, right? GM Global Propulsion. I like the sound of that.
Yeah, I think it for sure it won't hurt us in our recruiting efforts on campus. I think younger engineers are disproportionately interested in, let's call it, alternative propulsion systems. So they're more interested in that. Although, you know, when you go to Stanford or Cal Berkeley or other places, you know, you got a lot of motorheads, if you will, there too. So it's a mix. But I think it fits. Again, we think it says more about who we really are even today. That it's a better representation of kind of what we're doing.
Well, one other thing I'm really curious about when you do go out now, what typically do you still recruit from the pool? Is it mostly mechanical engineers, or are you getting more of these sort of mechatronic kind of, you know?
Yeah. The two main degrees that we recruit are still mechanical and electrical engineering, but mechatronics is so integrated into so many curriculums, and people are experts in mechatronics. Some of them are mechanical engineers, and some of them are actually electrical engineers. So there's a little bit of a blurring in there. So certainly mechatronics is a huge area, and but so degree-wise, it's mechanical engineering and electrical engineering, but the percentage of electrical engineering is for sure increasing. But we also hired this last year, again, the data is fresh with me, some chemical engineers, some computer science. So, because we're doing a lot more in software, as are others, a lot. So the software and controls is increasingly important to us. And we need a number of different backgrounds and skill sets to make that work.
You mentioned earlier that you have facilities around the world. Now, do you concentrate on different technologies in different places?
Yeah, well, one thing that I help, let's say, orchestrate with my global staff is kind of making it all play together and who's doing what where. So we do have a few areas that are overlap. So, for example, in gasoline engine development, we do that in a number of places. We do that in Pontiac in Michigan. We do that in Rüsselsheim in Germany, and in Korea and a few other places. So that's probably, which is a big part of our engineering workload, where we have the most. Others are less, let's say, duplicated, if you will. So a lot of the electric drive units is almost all here in the U.S. Diesel engines, we do the most of it in Turin, Italy, our Torino Engineering Center, but also supplemented by efforts here in Pontiac Engineering. So we try to rationalize it. Manual transmissions are, for example, concentrated in Germany. So we try and keep it rational, but there's a little areas of overlap. But we don't look at that as a problem. We actually look at that as an opportunity, because different great ideas come from everywhere around the world, and we try to figure out a way to make that play and really have a global organization. That's one of the things that I'm proud of, and we have global right in our name. It's not in name only. We really have true global leaders and true global organization that is working together and harmonized around the globe. That's a hard thing to pull off.
We got a lot of questions coming in here from the audience. Let's rip through a few of these. Propulsifier says, how long will GM keep producing pushrod engines? P.S. I love my LS1 Corvette.
Yeah, well, there's certainly great demand for them. Actually, you know, we think the small block is a competitive advantage for us. It enables some things in the Corvette, and it's certainly world class, and it's really great. We also think it's a winner in our full-size trucks, so we're super proud of that and the things that we're doing with it, and we're going to keep making them as long as customers continue to love them and buy them, and we're trying to enable that. So. Really, I anticipate for the rest of my career, however long that is, that we'll still be producing that as in our propulsion system portfolio.
Big cost advantage with pushrods too over overhead cam.
Well, my finance people tell me that
I hear it's $1,000 an engine. So that's what I hear. Espo wants to know, what are the improvements that you made to the 2016-2017 3.6-liter V6? I noticed the HP has gone up.
Yes, 335 horsepower, I believe, in the Camaro. So, by the way, we won Ward's 10 Best Engines for our new LGX high-feature V6 Gen 2, we call it. So it's got a lot of things. One of the things is the cylinder deactivation. So there's a V6 V4 mode. So we've taken that technology that we've been in production with on V8s for quite some time and applied it to the V6 engines. And then there's a lot of the other, things, friction reduction, efficiency improvements, so lots of little improvements. But from a customer-facing feature, maybe what they'll think about is the fuel economy associated with the active fuel management cylinder deactivation. It's really a great, great engine. I've been driving it around in our new Cadillac CT6, and it is really fabulous. But it's also great in the CTS, the ATS. We have it in the Camaro, so great.
I love it
great
in the Camaro. It's fantastic in the Camaro.
I'm convinced we have the best V6 Camaro we've ever had.
Fabulous.
And the whole powertrain lineup in the Camaro we're really proud of. We've got a great 4-cylinder turbo, we've got a great V6, and we've got great V8s, which is nothing new, but really proud of the lineup in the new Camaro. Fabulous car.
That V6 horsepower was V8 horsepower not all that long ago.
No, that's right. Yep. Okay, Armin wants to know, what's your view on using electrification for performance?
Yeah, well, you mean in production cars or in racing, or maybe both?
Maybe both.
Yeah, it's a great idea. It's concepts that we're looking at. It depends what kind of performance application that you want. If you want to improve your 0 to 60 mile per hour performance, it works pretty well. In a racetrack environment, you've got to think about electrification in a particular way, because if you want it to do lap after lap after lap after lap, then it gets into battery systems and some of the other things. So you got to take a total system design approach and understand the requirements and figure out what you want to do in racing applications or other performance applications.
Mm-hmm. Well, you were getting for the 5.3-liter engine with the e-assist is getting 13 horsepower increase.
Yep.
And 2 mile per gallon increase as well. So
exactly.
You guys
so we're using it to increase both performance and fuel economy. Mm-hmm. Yeah, exactly right. And that works in racing applications. But again, it depends exactly what the application is.
But the key is how it feels, right? Mm-hmm. Because I get in a lot of hybrids, and they deliver great fuel economy and they drive okay, but I don't have that connection of my right foot on the throttle pedal to the response of the car. There's a mushiness in between.
Yeah, probably those aren't the way. Must be somebody else's.
Okay, let me ask one more.
Let me say it this way. We spend a lot of time and effort really working on how the customer interfaces with the propulsion system. And that's through the accelerator pedal. It might be through the shifter if it's a manual transmission, but that's really, really important. How they perceive and interface with it is important. So we try to make all of those well-performing and well-perceived by the customers. There's really great ways to do that and to blend that. If you drive the new Chevrolet Bolt, I mean, it is exciting performance and very not mushy at all. I think the same's really true of the new Chevrolet Volt. So we're trying really, really hard to make those a great customer experience and responsive, because customers, we know what they like, and we're trying to give it to them more and more.
We've got another phone call that's come in here. Carmen, let's bring that one in now.
My name is Clem Zarobsky from Delmont, Pennsylvania. My question is, does the C7R engine use hydraulic roller tappets or mechanical solid roller tappets? The problem I was wondering about the solid tappets is, how do they keep them in adjustment for such long time periods like 24 hours? Thank you.
Yeah, thanks.
Good question.
Okay. I think you stumped me because I don't want to give the wrong answer, and I'm not 100% sure. So we'll have to get back to you on that one. But I will tell you, we ran over 30 hours of continuous dyno time on the actual Daytona track with this race engine. So we didn't just show up to Daytona and cross our fingers and hope we were going to make it. We really put them through rigorous testing to make sure they're going to have the durability so that we can start the race, finish the race, and actually race the whole way through. So these are 24-hour races that's racing the whole time.
Will this go to Le Mans?
This is going to Long Beach and Sebring. This
but an engine like it.
But like it, yes, will be at Le Mans.
Not this very one in the
engine
studio.
But this very one will be on a track.
Yes, this is headed to Long Beach. Yep, Long Beach and Sebring. It's the backup for one race and the star for the next.
They told me it's the backup for Sebring and we'll race at Long Beach.
Yep.
So I hope that's the one that wins.
Yeah, me too.
Yeah.
Okay.
Interesting note on that because one of the cultural things we do is we give the Winner's Circle Award. So twice a year, I present to teams that embrace the spirit of winning. So we're trying to build this winning spirit into our culture. And the award is a piston rod assembly from a winning engine from the Corvette.
So what kind of teams are you referring to? Teams, not
teams
racing.
or individuals. People in the organization,
like engineering teams.
Yeah, like they may do a super great analysis technique that helps us some way. They're nominated by their peers. Oh. So this is peer nominated, and when you have one of these on your desk, then everybody knows that you did something great and you can ask them about it. But we actually use the piston rods from winning Corvette engines as the award. So how cool is that to have that on your desk?
Perfect. Okay, Dennis from Canada says, if, and I mean if, GM was to build a lightweight mid-engine Corvette, what would be the ideal displacement and configuration for its engine to be?
Oh, that's a great question. What do you guys think? I like V8s. I'm pretty partial to V8s myself. But, I don't know about displacement because probably, there might be a range depending on the power level that you want to make. But
5.5 liters.
Yeah, that's a
good number. I mean, that's what you take out of endurance racing. That's the capacity limit there. And that seems to be Ford's making that same sort of connection between endurance and the GT road car.
With the V6 though.
Right. Well, right. But 5.5 V8, and you've got it right there already, right?
Well, let me say this. Probably something I can say. The connection between the track and the Corvette on the street will continue to be there for decades to come. So if you want to look for hints, look on the track, and you'll always be able to see the connection between what we race and what Corvette customers can buy from their Chevrolet dealer.
All right, speaking of decades to come, and this will be a future, and you can answer this one,
okay.
I think. Okay, so you've mentioned that you're putting cylinder deactivation on engines, you're using direct injection on engines.
Yep.
What are the enablers that you see that will allow the internal combustion engine to go forward, and how long do you think it will be until it becomes eclipsed by other propulsion technologies?
Yeah, that's a great question. Thanks for that. I don't have a crystal ball, so it's hard to predict. What I see is engineers continue to innovate, and it's really hard to predict their rate of innovation or where the next innovation will come from. When I look at what we're putting on the street today, the technologies and the level of integration and innovation, it was literally unforeseeable 10 years ago. How far we've come. The new standard powertrain in the Malibu is fabulous. It's a 1.5-liter turbocharged engine that delivers great performance, overall performance. You know, you couldn't have really foreseen that 10 years ago. So it makes it really hard to project exactly where we're going to be 10 years from now. I think what's happening in the industry with propulsion systems as well as other things is there's a lot of competition for who can meet the requirements in the most cost-effective way, and that makes it good for everybody. So we love electrification, we love those kinds of propulsion systems, and it puts pressure on, let's say, the engine guys to show what they can do. Okay, so how can you give me 3% improvement for, you know, $100 or $200? So this drives innovation if you have the right kind of environment where people are free to experiment and try new things, and so it's really hard to predict. I mean, we know over the next 5 years kind of what our technology cadence is and exactly what's going on, but we're working on so many things in the advanced stage that it's hard to know which ones are going to pay off, which ones aren't, and which ones will earn their way onto the car.
Hey, I want to tell the control room, we were going to have you leave at this point of the show, but let's keep going. Okay. Way too good. So, Carmen, we'll go on to the next break, and they're giving me the sign, another phone call's in. Why don't we bring that one in right now, Carmen? Okay.
We'd like to know why the LS7 isn't used more. The engine gets fantastic mileage, incredible performance. In its aluminum form, very lightweight and compact for the amount of power you can get out of that engine. It just the LS7 and of course naturally aspirated. It just why is it not used more, and even in the trucks?
Yeah, that's a great question. You will only hear me speak in favor of the LS7 engine. It's like one of my children. And speaking of children, I shout out to Kevin. It's your birthday today, so it's my son. Happy birthday, Kevin. So the LS7, you know, is great. The first SAE certified engine for horsepower, 505 horsepower. Really a fabulous engine. I mean, to have a over 10-year run in production for an engine is almost unheard of. So I'm really proud it had such a great run. It can go in as many things as you want it to go in, because you can go to your Chevrolet parts catalog and order an LS7 engine. It'll come in a crate. It's the world's best crate engine, and you can put it in everything you want. So what's great is you can still do that. But again, it had a really long life, and we're super proud of it. So that's probably all I can say.
Hey, I want to go back to Gary's question, because I really like that. You know, CAFE is getting tighter and tighter. Yep. It caps out at 2025. Mm-hmm. But when I talk to all the regulatory people at EPA or CARB or even the environmental community, they say, hey, that's just the first step. Yeah. We're going to ramp it up even more there. And of course, what they're focusing more on today than anything is CO2.
Yes.
How can the internal combustion engine continue in the future? Don't we have to start talking about fuels at this point, not just the engines themselves?
Yes, thank you very much. Because both people that are in the propulsion system business and environmentalists, I mean, this is one of the principles, understand that vehicles and fuels are a system, and they have to work together. I mean, that happens whether we're talking about when we took the lead out of gasoline in order to enable catalytic converters to clean the air, or whether we're talking about taking the sulfur out of fuel so that it wouldn't hurt catalytic converters, or it wouldn't hurt diesel engines and their after treatment systems. So vehicles and fuels as a system is the only way to look at it, and it's absolutely necessary. If we're going to keep improving fuel economy and CO2 reductions in the future, fuels need to come on the table. The Department of Energy has already done studies showing that on a well-to-wheel basis, improving octane is an absolute cost-effective way to go. So we're trying to engage with the industry, SAE, and others globally to try and really get the fuels that we need to continue to make internal combustion engines, in this case gasoline engines, viable into the future. I think they really have to come to the table, and 100 RON, research octane number, is really the mantra that I'm talking about in terms of where we need to be in the future. So I think that's, when I see 2025 and what we need, the fuels to enable these very aggressive targets, 100 RON fuel. So write your oil company and ask when they're going to come to the market with 100 RON fuel standard.
So, I mean, are you guys working with oil companies? I mean, does Chevron come into General Motors and say, okay, I want to work with you guys on developing new propulsion systems? Or is this basically a situation whereby you guys just go to your local station, get the fuel, and come back and work with it?
Well, we try to collaborate with everybody as much as we can, because we need partnerships in order to really work on and solve society's problems. And that's, we try to be proactive in working with a number of different entities, whether it's regulators or oil companies. So we're engaging as best we can and trying to get a solution and bring the facts on the table so everybody can see objectively what's going on. So this is where DOE can be a good third party, because they're trying to show the data and can sort things out. So it's not just, you know, auto companies saying, hey, give us more octane.
Yeah, but it's in the oil company's interest to do this. They shouldn't be sitting on their hands.
So it sounds like they ought to be more proactive.
Yeah.
Is that a way of saying
I would not disagree with you.
You guys keep making improvements in electrification. Yep. You keep making improvements in battery electrics. You're bragging about how you're only paying $125 per kilowatt hour for your battery for the Bolt. You're making big improvements on your fuel cell. I mean, don't the oil companies see that if they don't give you a 100 octane RON, and if they don't take carbon out of the fuel, I mean, they're cutting their own throats.
I think the most progressive elements in the whole, oil industry, refiners, as well as, the oil companies are seeing that, hey, some people are trying to design them out of the future, and really proactively engaging is a way to increase your longevity. Because I think without more octane, it's going to be very, very difficult to meet the CO2 target. So we really want to work together.
But how does the octane work? Because you can boost the compression ratio?
Yes.
Is that it's just that simple?
Yeah. Because we design our engines for the fuel systems that we have, and so we need a step performance here.
And so higher compression can lower CO2?
Yes, yeah, but exactly. Compression ratio, the relationship between compression ratio and efficiency is, let's say, well documented, and so we can only design, the fuels for the ones that are available that our customers want to put in them.
But I mean, you're not producing less CO2, you're just using less fuel with the higher octane.
And producing less CO2.
Oh, is that right?
Yes, yeah. The fuel consumption and the CO2.
You're getting more work out of out of a given amount of fuel, and so you can, depending on how much work you decide you want, you can use less fuel, right? Is that
so less fuel, less CO2?
Correct.
Right.
Exactly right.
You mentioned the LS7 having a 10-year plus run. Okay. Is it not the case now whereby, we used to think that engines would, 10 years, that's pretty average, that now you guys are having to develop engines at a pace that is unthinkable from...
There's never been a more exciting time to work in propulsion systems than right now. That's true not just at General Motors, but really as an industry trend. And what you see happening is both tailpipe emissions, fuel economy regulations, CO2 regulations, and relentless competition is really driving things a fast rate of change. And so we're having to develop them on a shorter cadence. And then we've got to amortize the capital. I mean, to do new engines, it's very capital intensive. We're talking about hundreds of millions of dollars. And so really, it's putting a lot of pressure on the industry. And you have to have scale, really, in order to be able to get returns from these. The small gas engine that's now in the Malibu, in 2 years, we're going to be producing one of those engines around the globe every 9 seconds. I was told last week. So we're selling that engine in the U.S. in the Malibu. It's coming in the new Cruise. It's the range extender that's in the Volt. It's already quite prolific with Opel in Europe, and the China volume is starting to ramp up. So when you add those volumes up together, it's quite big. So, luckily General Motors is a scale manufacturer, so we can kind of make the finances for that work. Smaller companies have a much harder time, and will find it more difficult to keep up from a technology standpoint.
So what would be the lifespan of an engine now versus the lifespan of an LS7?
Yeah, well, like I said, 10 years is kind of a surprise now. But that one was a 1 RPO unchanged, right? So what we can kind of do sometimes is, give a bit of a technology refresh after 5 years and hopefully not throw everything away. So, we're really carefully balancing technology, capital, and scale, and trying to make equations that work for customers and work for the business.
Hey, we got to take another quick break. Don't go away, Dan. This is way too good. We may have to dedicate the whole show to this. Carmen, let's get that next commercial break up. We got to give a shout out to our friends at Henkel.
A little chemistry goes a long way, especially when it comes to vehicle development. From enabling the use of alternate materials to withstanding extreme vehicle environments, Henkel's adhesive, sealants, and surface technologies provide solutions for every vehicle segment. Come see for yourself. Our Detroit area headquarters offers 12 research and development and testing laboratories with the ability to do full-range testing and validation on actual vehicle parts. Sign up to tour our labs at henkelna.com/tour.
Okay, we're back. One thing I've been dying to ask you about, Dan, is fuel cells.
Yeah.
You guys are partnered with Honda in developing a fuel cell, and I just read something recently from Charlie Fries saying that the reason that GM does not have a fuel cell car out right now is that it easily could, but you guys feel that the rate of development is coming so fast that anything that you'd put in the showroom today would be obsolete. Yeah, well, first of all, we do have a Honda partnership on fuel cell, and it's really a great partnership. We're very happy. This has been an example where in a technology, we've found a good partner. We're working together. We're really married with regard to fuel cells because we've put all our IP together. Honda doesn't partner with many companies. In fact, I couldn't name one other.
Yeah, they're pretty choosy in picking their partners. So we're proud, and we've got a great partnership. I was over there in October for our last steering committee meeting in Japan and meeting with top leadership, and both sides are very committed to the partnership. So it's really good. The fact that we don't have a car out there now shouldn't be taken as a reflection that we couldn't. But it's a serious commitment, and the cycles of learning are happening, this is Charlie's point, in such a fast manner that it's more important for us to keep up with the fuel cell technology than to, have a car program out there, for show. We've gotten the learnings that we needed from customers in our Project Driveway. Probably you remember that from a few years ago. That's where we had real vehicles in real customers' hands. We got a lot, exactly. We got a lot of learnings from that. And so we put that in our customer, data bank and what we learned from customers. And now we're focusing on the technology itself and trying to make it more cost effective. So there's certain learnings you get from doing a vehicle program. And we have nothing to announce today, but I see us doing programs sometime in the future. But I think we've chosen wisely in putting our research efforts in the past few years into fuel cell technology itself and not necessarily doing a car program. Because when you do a car program, it's all in, and you really have to deprioritize other kinds of things. So I'm pretty happy with the way we've chosen, and I'm very happy with our partnership with Honda. They're a good partner.
It's interesting that, you're mentioning fuel cells. You guys have extensive electrification programs going on. And you mentioned earlier that you guys are working on manual transmissions.
Yes.
It's just, it's mind-boggling to me that there would be such a diversity of technologies that you are in charge of around the world. Talk to us about that.
Yeah, thanks. It's, well, first of all, it's a great pleasure. It's really a passion of mine. I've been in and around powertrain, for most of my career, and I've had a chance to work. I was actually, interestingly, the first powertrain engineer at General Motors to work in China. So in 1997, even before we had the joint venture Shanghai GM, I was located in China for a special assignment. So I've got a chance to do that. I was 5 years working for General Motors in Europe. And so I know a lot of the technologies, I know a lot of the people around the globe, and so I feel lucky to have great colleagues and people that I can call and I know and trust around the globe. And that's part of what makes this work as a true global organization. We are dealing with a number of technologies, and okay, manual transmissions have been around a long time, right? But what's driving the development is, again, fuel economy, CO2, but the way they feel in the customer's hands. So European manual transmission drivers are still very particular about it working in a very precise, great feeling way. And so it takes a lot of great engineers to make that happen. And we've got some of the best in the business with our people in Rüsselsheim. So we're really proud of that. And China is still a very big manual transmission market. I mean, just in sheer numbers, actually, percentage-wise, it's not so much. But 15% of the largest car market in the world is still a very big number.
15?
Yeah.
That's a lot.
Roughly,
That's a lot.
on the whole, yeah,
Right.
on nationwide basis,
Right.
not so much in the cities, the bigger cities. So it's really important to us, and they have to be, with the fuel economy standards, the highest efficiency and also very cost effective. So you're always working, cost, efficiency, a lot of these fundamentals, and there's new ideas, there's new lubrication ideas, there's new, gear meshing ideas, there's technology development in that area as well.
I got to tell you, last week I got a chance to test drive the Camaro SS,
Yeah.
a 6.2 liter V8 and a 6-speed manual. And that was one of the stellar parts about that car, is how well that thing shifted.
Yeah.
I could not believe it, especially with that much power and torque going through it.
Yep.
It was a breeze to shift that thing.
Did you try the rev matching feature?
I did.
You like it?
I do like it. I'd rather heel and toe myself.
Yeah.
And there's times when you're in traffic and stuff like that, and you're getting caught out of guards. It's great to have the rev matching.
Yeah.
But if I got a great 2-lane road on my by no traffic, I want to do it myself.
The reason I
John
mentioned
probably wasn't going for the fuel economy either.
Yeah.
I just wanted to
But
point
the
that out.
rev matching we have as kind of a performance feature. So for the listeners that are out there, I mentioned rev matching because it's one of those features. My initial reaction was similar to that, sort of like, I know how to heel and toe. I'm a manual transmission driver. Who would want this? That was my gut reaction. And when you're at press events or other things, you're kind of in and out of cars, and you're really into it. And so maybe you don't see the value. But when you spend a long time, and Al Oppenheiser, who's legendary,
He's been on the show here too.
chief engineer of the Camaro, he was super skeptical and became convinced. He goes, when I drove the same car for 2 months in a row,
Right.
you love it, because then it becomes, you're used to it, and it's really great. So we have what I think is the best rev matching really in the business. It works fabulously, and when you have that as a daily driver and you get used to it, you really fall in love with it. So I'd encourage listeners that haven't tried that or seen it. It's really good. But we have it as a cancelable feature. So we got your pedal, you can turn it off if you don't want it.
Yeah.
But I think when you really try it, even if you're a dedicated heel and toe guy, you'll fall in love with it.
Do you guys do dual clutch transmissions?
Yes, we do. We have one right now that's quite successful in China. So it's a drive DCT technology that we put in production 3 or 4 years ago. It's sold in Buicks there, and it does quite well. So we were able to avoid a lot of missteps that you saw from others in the industry. And we have one of the highest ranking in terms of customer satisfaction DCTs in the market in China. And China is a very sophisticated market for transmission, feel, and things. So we're really quite proud of that. So your follow-on question is probably, how
I'll let you ask it.
When will we see
or
one?
there. We're pretty particular about knowing the markets, and the economics aren't quite working so well around the rest of the globe. For example, we have...
For DCT, you mean?
Yeah, for DCT. So, for example, our GF6 transmission, which we sell a lot in the U.S., is one of the most efficient conventional, so-called conventional front-wheel drive transmissions in the business, and very cost-effective. And so, the trade-off doesn't quite work for us with the installed base that we have in the U.S. market. And then for Europe, the torque range that it's in, the economics don't work quite as well. So we're continuing to look at it. We're actually looking all the time for market opportunities, but so far it hasn't quite popped up, except in China, where it's working quite well.
CVTs?
Yeah, we love the technology. We have it in the Chevrolet Spark today, and we have some forward-looking programs. I think that's a great technology you'll see more of. Some OEMs are almost kind of 100% converted over to CVT. I'm not quite that bullish overall, but love the technology and think it's got a really great place in the future. We have been very careful, and if you drive the Chevrolet Spark, to do it again, excuse me, in a customer-pleasing way. And so, customers in the past have complained or read comments of rubber band feel and, it's whiny or whatever. The way the propulsion system is integrated back to systems, is really, really important in making that feel good to a customer. So we're pretty proud of the Spark and the way that comes out, and that's emblematic of maybe where you'll see some of our offerings in the future.
Dan, we could go on and on. Yeah. I know you got a conference call that you got to get to.
Yeah.
Unfortunately, we're going to have to cut you loose right now, but it's been awesome having you on the show.
Yeah, thank you very much. Pleasure's all mine, and thanks a lot to all your viewers out there.
We're going to keep going, so Katie, maybe you can unplug him here so that he doesn't get clotheslined by the microphone wire. But thanks again, Dan.
Thanks again, John. Yep, take care.
Really good having you here.
Thanks. Yep.
Yeah.
Okay, great.
So good stuff there. And then, Gary, I know you had a couple of other topics you'd like to get into. Yeah, okay. Thanks, Dan.
Good to see you, Dan.
We can do that. We have a number.
Oh, Dr. Data's number. We got to get into that. So,
all right. So this is a number that. So this should provoke some conversation. So, all right, Carmen, bring the first slide up, please. Okay, so I was looking and I was thinking about, these are just car sales. So these are 2015 car sales.
It says nameplate efficiency.
So this is what I want to get to. So
you got Toyota, Chevrolet, and Ford, and you got numbers next to their logo.
All right, so basically in 2015, Toyota sold 1.1 million cars, Chevy, in the United States.
That's in this country.
And Chevy sold 767,000, and Ford 767,000. Ford 760,000. Okay, so then I got started thinking about that. So how efficient are they really? So Carmen, bring up the next number, please. Okay, so Toyota has 13 models, General Motors 10, and Ford 6.
Of cars.
Of cars. This is just
passenger
cars. Passenger cars. So Carmen will bring up the third. So I got to thinking, so if you look at that, that basically it's Ford is far more efficient per nameplate than even Toyota, even though Toyota just
at selling cars.
At selling cars.
This is great.
At trumping it. Okay. So if you look at that, so then I was thinking,
Oh, wait, just back up. All right. From an investment standpoint, from an advertising, or am I, okay.
This is exactly what I was thinking about.
Interesting stuff. This is really good.
So, there's the question of Scion, right? Mm-hmm. So Scion is part of the Toyota number.
That's 4 of the 13 models,
not the Lexus.
Oh, you included Scion in that Toyota
right,
number.
because the way Toyota reports, Scion's in there, right?
Right?
Now, even though the number of Scion units per se is very low, for the point of numbers, that Scion basically had 7.
Well, you're going to get argument, though, because right away you said nameplate, so you're going to get argument right there that Scion is a nameplate.
All right, well, however you want to look at it. So, so Ford had C-Max, Fiesta, Taurus, Focus, Mustang. Mm-hmm. Period, right? But Toyota had Camry, Corolla, Avalon, Prius, Mirai, Yaris, IA, IM, XB, XD, FRS, IQ, TC.
So Scion's killing Toyota from this standpoint.
From that standpoint of the efficiency. So so as you point out, the amount of money for,
you have to invest in the product.
You got to develop the product, right? You have the engineering costs.
Support the dealers, all that stuff.
Yeah,
right.
All the spare parts, all the advertising, marketing.
Right. Now, without Scion, without those things.
Show that one, Carm.
No, he doesn't have that one. So it's 185,000. Okay.
So even better than Ford.
Yeah, because Ford is basically
no wonder they're getting
at
rid
126.
Yeah, so no wonder they're getting rid of Scion.
So the point that it occurred to me, because I started thinking about that, is that in some regards, less is actually more for the automakers, right? Mm-hmm. Having fewer.
Right.
whatever you want to call them.
But that's not the trend of the industry. The industry has gone up in models. I think the trend line has been, as far as models themselves go, there's more models now than there ever have been.
Because they can be, because you're taking one architecture and doing 5 top hats on it.
Right.
But the question I have about that is that the most cost-effective way for them to do it?
It depends. And what depends is what's the incremental variable profit that you're getting off that extra model. So if it's an expensive model, it's probably worth doing. Yeah. If it's a Scion IM, I am not so sure.
Well, you have to be able to back out all those sort of soft costs, the marketing, the advertising, all that sort of thing. I think you'd really have to be able to back all that out to say, is an IA, actually profitable? That's what you're trying to get at, right? Is whether a particular model is actually contributing to the bottom line or whether it's not. And I think there have been over history probably numbers of vehicles that they did that didn't contribute to the bottom line.
Right.
Yeah, Honda has been famous for this. If you look at things like the Element, the CRZ, Insight,
just the kind of wacky
Cross Tour. Honda's another great example of this, where about 5 models account for 85% of the company's volume.
Right.
And you're like, why are you guys chasing these onesie-twosie things? It may make sense if you do something to bring in a new kind of buyer, generally a younger buyer, or like I said earlier,
Scion was trying to do.
Like Scion was trying to do, or if you bring in something that people got to pay for, and you can really make a lot of money off it.
Right, but it strikes me though. Even if we just compare Ford and Chevy, right? Ford has fewer than Chevy does, but if we look at that at sales per model, that Ford's got it all over them.
They do. No, they absolutely do.
So anyway, I thought that was sort of an interesting.
No, that's intriguing. That's a great way of looking at it.
Speaking of Honda, what do you make of the stop sale order on the Civic with the 2-liter engines for the wrist pin circlip, which I had to go look up. You probably
pretty simple item, really. It's something that when you see that, you think, wow,
is that the little snap ring that holds the wrist pin in
it's kind of a hard thing to foul up, really. It's it's unfortunate. Another black eye, really, right? This company that has so much of a renown for engineering, particularly engine engineering, right? To see these kinds of things tripping it up. And I think their new guy even made some allusion to that this week, did he not? Well,
they shook up their management.
Right.
They got rid of their chairman and 7 other top execs.
And the new chairman, in effect, said, we've had our eye off the ball for a long time. And openly. And that's something that's pretty rare,
Did they say their eye off the ball last year, too, though?
And the year before that.
Well, but exactly. The guy that was in there, Ito, or I can't remember his last name right offhand, but he's only been there since 2012, and so to get another new chief in early like that, I think is saying something that Honda knows internally. We really still have a lot to fix here.
But your point, it's such a simple little thing. This little clip.
It's something that I've tried to get at with some of the manufacturers for a few years now, and John kind of touched on, or you actually touched on it with Dan here earlier, is that as these product cycles start to get compressed, and you start to do everything faster and quicker and maybe with a shorter overall time span, I think you see things like this crop up, where...
That's a great point. That's a great point. In fact, we had Joe Hinrichs in the studio last year, from Ford, and he was saying Ford's actually going to add time to its product development cycle because of the very kind of issues you're talking about, Bill.
You just can't assure the quality that you want to assure, the reliability, when you start to compress these cycles. What I think it's starting to point out is that there may be almost a finite cycle time there, that once you start to shrink it any more than that, you are vastly increasing your potential for mistakes.
Unless you throw the right number of people at it. What has all these corporations been trying to do? Pare down their head count to the bare minimum possible and load up more and more work on everybody that's left.
And I do think that there just could be, no matter how many people you have, there's a finite amount of time that you need to run an engine in a dyno, let's say, to make sure that that pin is there, the little thing right on the end of the wrist pin.
But this is a manufacturing problem.
Well, so Gary, do they? Would you know? Do they buy their pistons with the connecting rod attached?
I mean, they used to make their pistons. I mean, I remember for years and years and years that you'd go down there and these guys would be machining their own pistons, and it was just incredible to me that they would do that. I got to believe they still do that. I mean, that it's a Honda company that's doing it. But, again, it just seems to me that if you look at where that, where you put the wrist pin in and then you put the little clip to hold the thing, I mean, it's just, I have a feeling that there was a failure on some of the insertions. I mean, I'm sure that this engine probably is dead nuts, workable and so on, but somebody just didn't put that in all of them, and so.
Well, they've seen a failure somewhere,
right?
And so rather than run the risk of saying, well, run it till it blows up and then we'll fix it, you get at it now.
Right.
I would suspect too that this is one of those things that is a reasonably straightforward fix. At least what the problem is. It's fairly easy to get at that component.
Right.
What was the number? 36,000.
Yeah, it was not a large.
42,000.
42,000.
Yeah.
Okay.
Right.
So they sort of know, or hopefully have control
what the universe is.
But it's expensive. Yeah. Holy moly! If you got to replace the engine or rebuild the engine in each one of those cars, yow.
Well, you got to at least pull the head, and I think who knows what their procedure is going to be?
You got to more than pull the head. You're going to have to pull the piston out of the block.
That's you got to get the head off and get at the piston, and but who knows what their solution may be? It could be to just throw a new engine in there.
I can't imagine that. Speaking of quality, so this was a big week for the Consumer Reports came out, and J.D. Power came out with their vehicle dependability studies. What do you guys make of that?
Well, to me, the stunning news is how well General Motors did in the J.D. Power study. Lexus was the absolute best brand by J.D. Power.
95 problems per 100.
But all Porsche four of GM's brands were above the industry average. That's very hard to do when you're the biggest car company in a market. To beat the average of the market, that's not easy to do. And Chevrolet was just a tick or two behind Toyota in that regard.
It was actually...
there it is there. We've got the graphic.
For those of you who
are not intimate with all this. Yeah.
So it was Porsche's number 2, Buick is number 3, Toyota's number 4, GMC's number 5, Chevy's number 6, Honda number 7, Acura 8, Ram 9, Lincoln 10, Audi 11. But Cadillac is down at 145. I mean, they're above industry average.
But here's the thing, and this is where I got problems with J.D. Power. I mean, basically, I buy this, what they've presented here. But also, they give the heaviest weighting in any kind of a defect to the connectivity part of the car. So if your infotainment system, Q, did you hear me say Q?
I mean,
everybody hates. Q, I believe, is the thing that's dragging down Cadillac in this ranking.
Right.
Look at Ford, second from the bottom.
Yeah.
Second from the bottom. Why? Because if you go back 3 years ago, that's when Sync first came out. Now we're up to Sync 3.
We should say that vehicle dependability study is of 3-year-old vehicles. So these are 2013 models. And see, and I just wonder, I wonder about what is the relevance of that?
Well,
especially, we just talked about faster cadence in terms of these product developments.
J.D. Power does their initial quality survey. That's measuring a car after only 3 months. As I've said, everything should work for 3 months.
Right.
So I think it's very worthwhile to go back after 3 years and say, okay, how now is it doing?
But again, I mean, isn't
well, the pace. I think that the pace. What you're getting at is something 3 years ago. Now, Sync, for example, is very different now. What you can buy than it was 3 years
up to
ago.
Sync 3, or they just produced
very improved and very different now, and so.
But I think the point is that okay, a lot of people they're not going to connect. They don't care about this stuff. The rest of the car is just fine.
Well,
I'm sure the Cadillac people would say, you know, I hate Q, but the rest of the car is fantastic.
But I mean, I'm sure that they would say, if I was Cadillac, I'd basically say, wait a minute, my portfolio has been changed over in the last 3 years. I mean, it's just, you know, how is this relevant unless somebody's going to buy a used Cadillac?
You have somebody grousing about that every year, really, with this study, is that, oh, well, we had 5 new model launches this year, you know,
but
in that particular year.
This is important, is because residuals are also set by what's your track record with this model.
Right.
And I mean, I can tell, I'm pretty sure, you know, Automotive Lease Guide looks at numbers like this to predict what should your lease rate be based on the track record that you've already shown.
Right.
I think the greater point here really is if you go back to what that study is titled, what is it called? Vehicle dependability, right? That used to mean, did you get left by the side of the road with your car? That, to me, is a fairly drastic thing, right?
Right.
Whether Q worked when you slid your finger across there to your satisfaction,
right?
I mean, it shows you how you know, what we've come to now with this stuff when it comes to dependability, you know. And I'm not downplaying necessarily all those features because they're important, because they are driver distraction-based things that, you know, potentially have importance, you know, at least. But to me, that, again, that's a different thing than saying what dependability used to mean, which your engine didn't break, right? You know, or something, you know, reasonably drastic with the operation of the car itself, as opposed to these things that are really kind of, at this point, you know, you're splitting hairs now, you know, when it comes to whether Q's worse than Sync 2 was or whatever, you know.
Yeah.
All right, so Consumer Reports came out with their April issue will be their car issue, and I know that you don't like Consumer Reports, but okay.
No. Okay, I don't trust their quality.
Okay. All right. So
it's good. The road tests are very good.
Okay. So let me read the list of their top categories. Okay. So best subcompact Honda Fit.
Okay.
Okay.
I'd agree with that. Best compact car Subaru Impreza.
I'm not so sure I'd go with that.
But it's not.
You're covering a lot of ground there.
Is it a bad choice?
No.
Okay. All right.
I'd call that a very
Even though
average
J.D. Powers rates it way down.
Right.
But that was VDS or whatever.
Yeah.
This is new stuff. Okay, midsize car Camry.
Yeah.
Bulletproof.
Hard to go with that.
Small SUV Subaru Forester.
Yeah.
Okay.
Maybe.
They like their Subarus there. They do.
In that part of the they're in Connecticut.
It's right.
It
is.
It's
very New Englandy there.
That part of the world, they just love Subarus. Luxury SUV Lexus RX. I think that's.
Subaru doesn't have one of those. So they...
Sports car under $40,000 Miata.
Of course.
Yeah.
Okay. Large car Chevy Impala.
Yeah.
Great car.
Midsize SUV Kia Sorento.
Sorento hasn't done that.
That
well
one
in
raised
the
my
market.
eyebrows a little bit too when I saw it.
All right.
Yeah.
Pickup F-150.
Yeah.
It's like motherhood and apple pie.
Right.
F-150. Well, I guess.
Yeah, wrong tagline.
Apple
right?
pie was with those other guys. Yeah. Minivan Toyota Sienna.
Yeah, I think I.
And that's their list.
Yeah. Now the other thing is they also put out the worst of the worst list.
Yeah.
And I was so interested.
That one's usually more interesting, right?
The Tesla Model S.
Oh, geez, and you.
Yeah, I know. Anton turned me on to this, but he's right in this regard. I mean, when they tested the S, they said it's the best car we've ever tested.
Broke our scale.
It broke our scale. Yeah. And now when you look on the worst of the worst cars, which they recommend you do not buy, what's on there?
Right.
The Model S.
And as I had pointed out, and you were on this to Anton, that BMW has several cars on the do not buy under any circumstances.
Not just Tesla.
So it's not just Tesla. I think we had to make that.
There's quite a few brands, the worst of the worst. But I just thought to go from here's the best we ever drove to we recommend
none of those BMWs broke the meter, right? Yeah, they didn't break the meter.
But Tesla still has the would buy again crown.
Sure.
So more people will still buy them despite that, and we also saw that Tesla increased their towing to 500 miles this. So if your car breaks, they'll tow you for 500. So you're left on the side of the road and you have a Tesla, 500 miles.
You're in like Flint.
You can go practically anywhere.
Some of this does point to the sort of the disconnect though between a lot of these things and even the J.D. Power metrics too. That okay, here's what we measured and here's what we derived from that, but people don't care about that. You know, they're blown away by their Tesla, right? They're
well, it also calls into question, so for example, if we go back to the JD Power list, Subaru's way down.
Right,
the
exactly.
list.
Right.
Jeep is always way down. Those are two of the best-selling brands and have been for years.
Right.
And for years, they've been way down the list.
Everybody knows it.
So then you have to call into question, okay, again, this gets back to your question, Gary, how relevant are these surveys when some of the best-selling cars score very poorly, and it goes on for years. So it's not just a one data point kind of evaluation. It goes on for years like this.
Well, again, what are you measuring? Because you can measure a lot of things and derive some sort of conclusion from that, but it doesn't necessarily match up with what's going on in the market, which is Jeeps don't stay on the lot now, and no one seems to be concerned about that, and haven't been, like you said, for forever, really,
Hey, we've gone over our normal time limit. We should probably wrap this up, even though this has been terrific. That's why we've gone long with it. But Bill Visnic, thanks for coming in here, man.
John.
We're going to have you back.
I like coming.
Well, Dan Nicholson was terrific.
Yeah, he was great.
That was excellent. So, Gary, you're in the driver's seat next week here on the show because I'm going to be out of town. I'm going to be out driving the Cadillac XT5.
I'll see you there then.
You're going to be on that one too? Okay.
All right.
Dan drove up in one today. I told him, hey, save me a trip.
I saw that out there. I'm like, what the?
Hey, let's just let us drive it around right now. We can save a trip to California, right?
Yeah.
Okay.
Good looking car.
Okay, well, let's wrap it up. Thank you all for having tuned in.
Autoline After Hours is brought to you by Bridgestone Tires, your journey, our passion, and by Henkel, excellence is our passion.
Visit our website, Autoline.tv, where you can watch us live. Get your daily news fix with Autoline Daily and in-depth analysis and interviews with Autoline This Week. There's all that and much more at Autoline.tv.